Okay, part 2. Still dealing with slope. We're going to look at like table of values, which is basically points, which I'll show you here in just a little bit. So if we're looking at slope in that case, we don't want to use rise over run. We want to use y2 minus y1 over x2 minus x1. You should already have it in your notes, but that's your formula for slope. Okay, so here's a table of values. And you can pick any two off of this table. I'm not going to show you with every single one, but let's just pick the first two. Okay, so I have the point -4, 6, that's the ordered pair, and I have the point 0, 8, there's my other ordered pair. y2 minus y1 over x2 minus x1. y2 is 8 minus 6, and then x2 is 0 minus -4. Oh, that's crazy. 0 minus -4. This is actually 8 minus 6 over 0 plus 4. 8 minus 6 is 2. 2 over 4 reduces down to 1/2 because you want full credit for your slope there. And you have slope of 1/2. Okay, and if you check it with any other 2 points, and you could pick this one and this one if you wanted. Okay, 12 minus 8 is 4. 8 minus 0 is 8, so you would have 4 over 8, which is 1/2. So that would work as well. So I want you to be aware you can do it like that. All right, clearing all that out, let's just start here. Pick 2 different points. Here, I'm going to pick all these negatives so I can show you one with a lot of negative numbers. So I've got the point -6, -3, and I've got the point -4, -6. Quick remind ourselves, y2 minus y1 over x2 minus x1. Lovely. y2 is -6 minus -3. So I'm going to do minus -3. That's a lot of negatives in there. So now I'm going to take -4 minus -6. Let me rewrite this. And what I usually do on a piece of paper, if it were just me, I would do kind of this funky little plus thing over the top of that and a plus over the top of that, so I don't have to spend the time completely rewriting. All right, so -6 plus 3 is -3. -4 plus 6 is 2. So I have a slope of -3 over 2, which if I graphed all these points and then went rise over run, I would have -3 over 2. I would see a negative sloped line. Now, I'm just going to point this out because I think this is kind of interesting, and this only works if your table is counting by equal increments, which happens a lot. I just set it up that way almost all of the time in my algebra class when we're learning this. Remember this good old change in y over change in x? What's the change in the y column if I continue on down this pattern? I'm subtracting 3, subtracting 3, subtracting 3. And if I look at my change in my x column, I'm adding 2, adding 2, adding 2. Change in y is -3. The change in the x column is +2. Oh, that's what I had originally, isn't it? Oh, goodness. That's kind of interesting if that happened like that. Okay, let's try another one here. Pick 2 points. It doesn't matter which points. I have a feeling, though, if you could pick anything you wanted, let's go with the zeros, man. Let's just make our lives a little easier there. So I've got a 0, -4, and I've got a 5, -5. Change in my y's. So I've got -5 minus -4. Ooh, look at how sneaky I was there. And then I'm going to take 5 minus 0. So now I have -5 plus 4, which is -1. 5 minus 0 is 5. -1/5. Let's do the sneaky route. Change is, oh, I gotta be careful with that. That's a -1. -1, I have to keep subtracting 1 to get to the next number. And when I go on this side, I'm adding 5. I keep adding 5 and I keep adding 5. Change in y over change in x. -1 over 5. This is all about patterns. It's a pattern thing all the way, this linear stuff. Once you've got the pattern, you are good. good to go. Oh, let's find our rate of change, aka slope, right? And let's pick this point and pick that point right there. 0, 0, and then 1, 1. What if it's written like that? Will that freak you out? Here are your y's. 1 minus 0. Here are your x's. 1 minus 0. 1 minus 0 is 1. 1 over 1 reduces to 1. So in other words, I have a slope of 1 here. Let me do my little quickie fling through here. So -2 to -1 means I add 1, I add 1, I add 1, I keep adding 1 on this side. If I go this direction, every time I move down the column, I'm adding 1. Once again, this only works if you have a table that's counting by equal increments. Otherwise, you have to go back to y2 minus y1 over x2 minus x1. But if I do change in y over change in x, I get 1 over 1, which gives me 1. Isn't that crazy how that works? Okay, let's look at our special cases now. Oh yeah. Once again, I'm going to pick this one, and I'm going to pick, let me pick that point right there. 0, 5, and 2, 5. y2 minus y1, 5 minus 5. 2 minus 0. 5 minus 5 is 0. 2 minus 0 is just 2. 0 over 2 is just 0. This particular table has a slope of 0. And if you if I had graph paper right now, but let's just do a sketch graph. -2, 5. -1, 5. 0, 5. 1, 5. Oh my gosh, those are all those dots. If you were to graph that out, you'd have a line like this. And if you think about Mr. Potato Head, your slope would be 0. Okay, let's go on to this one. Let's pick the easy 2 points right there. So I've got a 5, 0, and I've got 5, 1. So I take y2 minus y1, x2 minus x1. I get 1 over 0, and we know we can't divide by 0. This is when I know you want to put down like empty set or something like this, but remember when we talk about it in linear equations, we're calling the slope undefined. And this is an undefined slope, which in our minds we should be thinking, what does the picture of that look like? If I were to graph this and graph all these points, 5, -2, 5, -1, 5, 0, 5, 1, 5, 2 would graph into a line like this. Oh yeah, that vertical line. Oh yeah, it has undefined slope. Mr. Potato Head is undefined when he tries this kind of workout. Oh yeah. Okay, and if you go this route, just want to point this out too, your change is +1, but your change over here is 0. So your change in y is 1, your change in x is 0, so 1 over 0. So those numbers are just not coming out of nowhere, all this math. You can do a little bit of a shortcut if you would like with that. All right, final thing here. If you had to graph a line with a particular slope, you have to have a starting point. Eventually, our starting point, see there's my starting point, woo, is usually somewhere on here. I mean, that's eventually where it's going to go, but I can stick it anywhere I want. I'm sticking it right there. If I want to have a slope of 4, then I would start with this dot right here, and if I do slope of 4, I need to have a rise over run. But wait a minute. I don't have a top number and a bottom number. Or do I? 4 is the same as 4 over 1. Right? 4 is the same as 4 over 1. So if that's the case, my rise would then be 4, and my run is 1. I put a dot. Rise 4, run 1. Okay? And what I suggest is you make a good 3 or 4 points, across the page. I mean, there's special cases where you don't do that. But here, I can't, oh, wait a minute. Isn't that equivalent to -4 over -1? Yeah, -4 divided by -1 is 4. So from here, I could rise -4 and run -1. Rise -4, run -1. Okay, and if I were to make a line through this, let me see if I can make my fancy line. Oh, what happened to my There's my fancy line. There we go. That would be my graph. Okay? And I just have to have my starting point, and I just kind of go from there. Let's try negative 2/3. Okay? Let me move my dot somewhere else. Let's go right there. So from there, I will take my dot, that's my starting point, and I'm going to rise negative 2, run 3, put a dot. Rise to negative 2, run positive 3. Rise negative 2, run positive 3. You're like, what if I wanted some dots, or I run out of my paper? My paper runs out right there. You need just a couple more. Is it negative 2/3? Sorry, let me write it like this. Isn't that the same as 2 over negative 3? Yeah. So from this dot, I could rise 2, run negative 3. Rise 2, run negative 3. Okay? And then I just make my fancy schmancy line. I don't think I do sometimes. Oh, the line is straight. I don't think I actually put it in a straight spot. But that's what you would have. That would be graphing the line with the slope of negative 2/3. Double check. You have a negative number. Do you have a slope that's negative? Because those are the things you do not want to miss on a test or a quiz or something. Okay, let me move my dot. This time I'm going to move it to a spot where it normally kind of hangs out along this line. It's a favorite starting spot. We don't have to use it, but we often do. That looks like a wonderful place to start. I have a slope of negative 3. Once again, I have to do the rise over run. And you're like, I only have one number. Oh, but there is another number hidden out right here. It's over 1. So from this dot, I rise negative 3, run 1. Rise negative 3, run 1. Rise negative 3, run 1. And if I wanted to go the other way, it would be 3 over negative 1. Most of us can pattern it out. Down 3 over 1, down 3 over 1, then go up 3, back 1. Up 3, back 1. Okay? And then you make the line through those points, and everybody's happy. Okay? Let's do the last one here. It looks like I have a slope of 1/2. I need my starting dot. I'm going to put it right down here. Okay, and I have a slope of 1/2. So from this dot, I will rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Oh yeah. And if I go the equivalent of negative 1/2, the fraction that I can think of right off the top of my head that's equivalent would be negative 1 over negative 2. Never leave that as your answer, but you can think rise negative 1, run negative 2. Look at that. That's amazing. Okay, and now make my line. Beautiful. That's how you graph a line with a slope of whatever is given, giving a starting point. Okay, and then the worksheet. Wonderful.